Dear students, in this video lecture, we are going to discuss about principal axis theorem. So in the last video session, we discussed about the quadratic form of equations. Quadratic form of equations means a particular equation which is expressed in terms of second degree, that is termed as quadratic form. So regarding the quadratic form of equations, we are having some of the geometric figures like circle, ellipse, hyperbola, then a pair of straight lines. All these things are expressed in case of a quadratic form. So based on our quadratic form of equation, we have to identify what type of conic section the corresponding equation denotes. So here, these are some equations to familiarize or to remember the concept of geometric figures like circle, ellipse, hyperbola, and pair of straight line. In case of a circle, the general equation is x square plus y square is equal to a square, or it can be represented as y1 square plus y2 square is equal to r square, where r is the radius of the corresponding circle. And regarding the case of ellipse, it can be denoted as x square by a square plus y square by b square is equal to 1. So in our terms, it can be written as y1 square by a square plus y2 square by b square is equal to 1. And the equation for a hyperbola, it is x square by a square minus y square by b square is equal to 1, or it can be represented as y1 square by a square minus y2 square by b square is equal to 1. And regarding the case of a pair of straight line, it can be represented as y1 square plus y2 square is equal to 0. These are some of the commonly used geometric figures which should be expressed, whose equation should be expressed in terms of quadratic forms. Let us see the principal axis theorem. Let A be a symmetric matrix with eigenvalues lambda 1, lambda 2, lambda 3, etc. lambda n, and corresponding eigenvectors are v1, v2, v3, etc. vn. So we are having a symmetric matrix A. Symmetric matrix means A is a square matrix. The transpose of square matrix, this square matrix A will be equal to A. So such type of matrices are termed as symmetric matrices. This symmetric matrix A is having eigenvalues lambda 1, lambda 2, etc. lambda n, and v1 be the eigenvector corresponding to lambda 1, v2 be the eigenvector corresponding to lambda 2, likewise vn be the eigenvector corresponding to lambda n. അതായത് നമ്മുടെ കയ്യിൽ ഒരു സ്ക്വയർ മെട്രിക്സ് എ ആണുള്ളത്. എയും എയുടെ ട്രാൻസ്പോസും ഈക്വൽ ആണ്, അതുകൊണ്ട് തന്നെ എ സിമെട്രിക് ആണെന്ന് പറയാം. ഈ സിമെട്രിക് മെട്രിക്സിന് n നമ്പർ ഓഫ് ഏജൻ വാല്യൂസ് ഉണ്ട്, ലാംഡ 1, ലാംഡ 2, എക്സെട്ര ലാംഡ n വരെ. ഓരോ ലാംഡ 1നും കറസ്പോണ്ടിങ് ഏജൻ വെക്ടർ ഐഡന്റിഫൈ ചെയ്തിട്ടുണ്ട്, v1, v2, എക്സെട്ര vn തന്നെ. Now what we are going to do is, if it form the orthogonal matrix n, normalized model matrix, then the substitution x is equal to ny transforms quadratic form to principal axis form. നമുക്ക് ഈ ഏജൻ വെക്ടർ വെച്ചിട്ട് നോർമലൈസ്ഡ് മോഡൽ മെട്രിക്സിനെ ക്രിയേറ്റ് ചെയ്ത് ഈ ഇക്വേഷനിലേക്ക് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്ത് കഴിഞ്ഞാൽ, എക്സ് ഇസ് ഈക്വൽ ടു എൻ വൈ എന്ന് പറയുന്ന ഇക്വേഷനിലേക്ക് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്ത് കഴിഞ്ഞാൽ പ്രിൻസിപ്പൽ ആക്സിസ് ഫോമിലേക്ക് ആവും. നോർമലൈസ്ഡ് മോഡൽ മെട്രിക്സ് എന്ന് പറഞ്ഞാൽ ഏജൻ വെക്ടർ ഡിവൈഡഡ് ബൈ ഇറ്റ്സ് നോർമലൈസ്ഡ് ഫോം. ആ രീതിയിലാണ് നോർമലൈസ്ഡ് മോഡൽ മെട്രിക്സ് ക്രിയേറ്റ് ചെയ്യുന്നത്. മോഡൽ മെട്രിക്സ് നമുക്കറിയാം എങ്ങനെ ക്രിയേറ്റ് ചെയ്യുന്നതെന്നുള്ളത്. ഏജൻ വെക്ടർ വെച്ചിട്ടാണ്, ഓരോ ഏജൻ വെക്ടറും ഓരോ കോളമായിട്ട് വരുന്നതാണ് മോഡൽ മെട്രിക്സ്. അതിൻ്റെ കൂടെ നോർമലൈസ്ഡ് അതിനെ വെക്ടറിനെ ഡിവൈഡഡ് ബൈ നോർമലൈസ്ഡ് ഫോം ഓഫ് വെക്ടർ ചെയ്യുമ്പോൾ നോർമലൈസ്ഡ് മോഡൽ മെട്രിക്സ് ഒബ്റ്റെയിൻ ചെയ്യും. ആ എന്നിനെ എക്സ് ഇസ് ഈക്വൽ ടു എൻ വൈ എന്ന് പറയുന്ന ഇക്വേഷനിലേക്ക് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുമ്പോഴാണ് പ്രിൻസിപ്പൽ ആക്സിസ് ഫോമിലേക്ക് വരുന്നത്. നമ്മൾ ക്വാഡ്രാറ്റിക് ഫോമിൻ്റെ കേസിൽ ക്യൂ ഈക്വൽ ടു എക്സ് ട്രാൻസ്പോസ് എ എക്സ്, ക്യൂ ഈക്വൽ ടു എക്സ് ട്രാൻസ്പോസ് എ എക്സ് എന്ന് പറയുന്ന ഒരു ഇക്വേഷൻ ഡയഗണലൈസ് ചെയ്യാൻ വേണ്ടി പഠിച്ചു. അതേ രീതിയിൽ തന്നെ നമ്മൾ ഈ ഒരു ഇക്വേഷന് പകരം എക്സ് ഇസ് ഈക്വൽ ടു എൻ വൈ എന്ന് പറയുന്ന ഫോർമാറ്റിലേക്ക് ആക്കിയാൽ നമുക്ക് കറസ്പോണ്ടിങ് ആയിട്ടുള്ള പ്രിൻസിപ്പൽ ആക്സിസ് ഫോം ഒബ്റ്റെയിൻ ചെയ്യാം. അത് എക്സാമ്പിൾ വെച്ച് കാണിച്ചു തരാം. So we are having the first question. Find out what kind of conic section are 3x1 square plus 22x1 x2 plus 3x2 square is equal to 0 and transform it into principal axis form. So we are having a quadratic equation with us, and we have to find out what type of conic section this particular quadratic equation represents, and also we have to transform it in the format of principal axis form. Principal axis form means നമ്മൾ മുമ്പ് തൊട്ട് മുമ്പുള്ള സ്ലൈഡിൽ കണ്ടിരുന്നു. പ്രിൻസിപ്പൽ ആക്സിസ് ഫോം എന്ന് പറയുന്നത് x is equal to ny എന്നുള്ളൊരു ഫോർമാറ്റ് ആണ്. അതേ രീതിയിലേക്ക് ഇതിനെ ട്രാൻസ്ഫോം ചെയ്ത് എഴുതാൻ പറ്റണം. x is equal to ny എന്ന് പറയുന്ന ഒരു ഫോർമാറ്റിലേക്ക് ഈ ഒരു ഇക്വേഷൻ ട്രാൻസ്ഫോം ചെയ്ത് എഴുതാൻ പറ്റണം. So we will start our solution. First we have to write the quadratic form. Given quadratic form is 3x1 square plus 22x1 x2 plus 3x square is x2 square is equal to 0. Based on that quadratic form, we have to create the corresponding coefficient matrix. Coefficient matrix create ചെയ്യുമ്പം ശ്രദ്ധിക്കുക, ഇവിടെ നമുക്ക് രണ്ട് വേരിയബിൾ ആണുള്ളത്, x1 ഉം x2. അതിനെ ബേസ് ചെയ്തിട്ട് വേണം, അപ്പോൾ റോ വൈസും കോളം വൈസും x1 x2 എഴുതി എന്നിട്ട് വേണം coefficient matrix create ചെയ്യാൻ. So our coefficient matrices we have to take x1 as the first row and first column and x2 as the second row and second column. So x1 square, this position is x1 square, coefficient of x1 square is 3. Then this position is x1 x2, we are having x1 x2 as 22. So we are having x1 x2 as well as x2 x1. So 22 divided by 2, 11 will be here and 11 will be in x2 x1 position. Then the next position is x2 square coefficient, that is 3. So our matrix is 3 11 11 3. Now we have to find out the characteristic equation of this particular matrix. The characteristic equation can be found out as a minus lambda I is equal to 0. Determinant of a minus lambda I equal to 0. So we have to take the determinant of a minus lambda I. A minus lambda I means here we have to represent as 3 minus lambda 11, 11 3 minus lambda determinant. So it will be evaluated to identify the corresponding characteristic equation. We obtain the characteristic equation as lambda square minus 6 lambda minus 112 equal to 0 is the characteristic equation. Now we have to identify who all are the roots of this characteristic equation, and the roots will be the eigenvalues. So here the roots are 14 and minus 8. So our eigenvalues are 14 and minus 8. So by using this eigenvalue, we can represent the quadratic form into a corresponding canonical form. The canonical form can be represented as, the general format is q is equal to lambda 1 y1 square plus lambda 2 y2 square, where lambda 1 and lambda 2 are the eigenvalues. So we can represent the corresponding eigenvalue as 14 y1 square minus 8 y2 square is the canonical form of given quadratic equation. Now we have to identify what type of conic section this particular canonical form represents. So regarding the case of pair of straight line, the equation is like this: y1 square plus y2 square is equal to 0. Here the same format, we are having, instead of 1 we are having 14 y1 square, and 1 y2 square, it is minus 8 y2 square. So we can say that this quadratic form will represent a conic section that is a pair of straight line. That is important because our first question is find out what kind of conic section the corresponding quadratic equation belongs to. So our first answer is the conic section is a pair of straight line. Now we have to find out the transformation to principal axis form. For that we have to consider the eigen vector for lambda equal to 14. We have to consider the first eigenvalue, that is lambda equal to 14. So we have to identify the eigenvector for lambda equal to 14. For that we have to calculate a minus 14i. So the change should be happened on the diagonal elements. 3 minus 14, 11, 11, 3 minus 14, and if this corresponding thing is evaluated, we get the equation as minus 11x1 plus 11x2 is equal to 0, and we can write it as minus 11x1 is equal to minus 11x2. So cancelling minus 11 from both sides, it will be x1 equal to x2. So x1 equal to x2 means that s1 is equal to 1, x2 is also equal to 1. So the eigenvector when lambda equal to 14 is 1, 1. So our eigenvector is represented by x1. The value is 1, 1, and we have to find out the corresponding uh, normalized form of this corresponding vector. That is, x1 normalization can be written as square root of 1 square plus 1 square, which is equal to square root of 2. Likewise, we have to find out the eigenvector for second root. So that is, second root is second eigenvalue is lambda equal to minus 8. So we have to identify a minus minus 8i, that is a plus 8i. So the change will be happened on the diagonal elements. 3 plus 8, 11, 11, 3 plus 8. So 11, 11, 11, 11 is the corresponding matrix. Now based on this matrix, we have to write down the equation. So our equation is of the form 11x1 plus 11x2 is equal to 0. So we can write it as 11x1 is equal to minus 11x2. That can be, 11 is common on both sides. So x1 can equal to minus x2. So if x1 is equal to 1, x2 will be equal to minus 1. So our eigenvectors corresponding to lambda equal to minus 8 is 1 and minus 1. So lambda equal to minus 8, x2 is equal to, or the eigenvector x2 should be equal to minus 1, 1. So what we are going to do is we have to find out the normalized form of this x2. So x2 will be equal to square root of minus 1 square by plus 1 square, which is equal to square root of 2. Now what we are going to do is we have to construct our normalized model matrix. Normalized model matrix N can be constructed as a sequence of eigenvectors. So here, in case of previous case, that means the diagonalization of matrix model matrix create ചെയ്തത് agent vector direct എഴുതിയിട്ടായിരുന്നു. പക്ഷെ ഇവിടെ normalized model matrix create ചെയ്യുന്നത് agent vector എന്താണോ വന്നത്, ആദ്യത്തെ agent vector എന്ന് പറയുന്നത് 1 1 ആയിരുന്നു വന്നത്. 1 divided by normalize ചെയ്യാൻ വേണ്ടി അതിൻ്റെ square root of its sum of squares വെച്ച് divide ചെയ്യും. അതായത് നമുക്ക് തൊട്ട് മുമ്പ് അതിൻ്റെ നോർമലൈസ്ഡ് ഫോം ഓഫ് x1 എന്ന് പറഞ്ഞ് കിട്ടിയേക്കുന്നത് സ്ക്വയർ റൂട്ട് ഓഫ് 2 ആയിരുന്നു. സോ 1 by square root of 2. Then the second value in the first vector is 1 by square root of 2. അതേപോലെ സെക്കൻഡ് ഏജന്റ് വെക്ടറും, ഇതാണ് സെക്കൻഡ് ഏജന്റ് വെക്ടർ കിട്ടിയത്. മൈനസ് 1 ഉം 1 ഉം ആയിരുന്നു. സോ മൈനസ് 1 ഡിവൈഡഡ് ബൈ സ്ക്വയർ റൂട്ട് ഓഫ് 2, 1 ഡിവൈഡഡ് ബൈ സ്ക്വയർ റൂട്ട് ഓഫ് 2. ഇതാണ് നമ്മുടെ നോർമലൈസ്ഡ് മോഡൽ മെട്രിക്സ് എന്ന് പറയുന്നത്. നോർമലൈസ്ഡ് മോഡൽ മെട്രിക്സ് എന്ന് പറഞ്ഞാൽ ഇത്രേ ഉള്ളൂ. ഏജന്റ് വെക്ടറിൽ എന്തൊക്കെയാണോ വാല്യൂസ് കിട്ടിയത്, സ്ക്വയർ റൂട്ട് ഓഫ് സ്ക്വയേഴ്സ് ഓഫ് ദാറ്റ് പെർട്ടിക്കുലർ വെക്ടർ വാല്യൂസ്. അപ്പോൾ ഇതേ രീതിയിൽ നോർമലൈസ്ഡ് മോഡൽ മെട്രിക്സ് n കിട്ടി. ഇനി ഇതിനെ പ്രിൻസിപ്പൽ ആക്സിസ് ഫോമിലേക്ക് കൺവേർട്ട് ചെയ്യണം. പ്രിൻസിപ്പൽ ആക്സിസ് ഫോമിന്റെ ഇക്വേഷൻ x is equal to ny. So we can write it as, x can be written as x1, x2, and n the matrix itself, 1 by square root of 2 minus 1 by square root of 2, 1 by square root of 2, 1 by square root of 2 into y matrix, y1 into y2. So we have to do the matrix multiplication on the right hand side. So it will become x1 will be equal to 1 by square root of 2 into y1 minus 1 by square root of 2 into y2, and x2 is equal to 1 by square root of 2 into y1 plus 1 by square root of 2 into y2. So this is the principal axis form of given quadratic equation. Let us see the second question. Find out what kind of conic section are 17x square minus 30xy plus 17y square equal to 128, and transform it into principal axis form. So we are having a quadratic equation. 17x square minus 30xy plus 17y square is equal to 128. We have to identify what type of conic section this particular quadratic equation refers to, and also we have to transform the corresponding quadratic form to principal axis form. So we will start the corresponding solution for this particular question. First of all, we have to identify the quadratic form, that is 17x square minus 30xy plus 17y square is equal to 128. Then by using this quadratic form, we have to identify the coefficient matrix A. So here you can see that we are having two variables x and y in the quadratic equation. So we have to create the coefficient matrix based on this x and y variable. We have to consider x and y row wise and column wise. So this is x row and this is y row. This is x column and this is y column. So x into x square coefficient is 17. Then xy we are having minus 30 with us. We have xy as well as yx is there, so minus 30 divided by 2, that is minus 15 here, and minus 15 is plotted here. So minus 15 plus minus 15, it is minus 30. So this position is y square, y into y square position. Coefficient of y square is 17. So our coefficient matrix is 17 minus 15 minus 15, 17. So what we have to do, the next step is we have to identify the characteristic equation based on this coefficient matrix. For identifying the characteristic equation, we have to use the determinant of a minus lambda I is equal to 0. So we have to identify a minus lambda I. We can make the corresponding substitution on the principal diagonal elements, that is 17 minus lambda minus 15 minus 15, 17 minus lambda. So if you are solving this particular determinant and equal to 0, we obtain a quadratic equation of the form lambda square minus 34 lambda plus 64 is equal to 0. This is the characteristic equation of this coefficient matrix. Lambda square minus 34 lambda plus 64 is equal to 0. So our characteristic equation is lambda square minus 34 lambda plus 64 is equal to 0. The roots of this quadratic equation is 2 and 32. So 2 and 32 are the eigenvalues of this characteristic equation. Now we have to write down the canonical form. Canonical form can be expressed as Q. Q is equal to lambda 1 y1 square plus lambda 2 y2 square. Here lambda 1 equal to 2 and lambda 2 equal to 32. So Q can be written as Q is equal to 2 y1 square plus 32 y2 square, and this will be equal to 128. 128 is a constant term which will be given on the right hand side of our given quadratic form. So we can write it as 2y1 square plus 32y2 square is equal to 128. Now we can have 128 on the right hand side. So in order to make it as 1, we have to divide both sides by 128. So it will become 2 by 128 y1 square plus 32 by 128 y2 square is equal to 128 by 128. So we obtain the corresponding equation as y1 square by 64 plus y2 square by 4 equal to 1. So our equation is now in the form y1 square by 64 plus y2 square by 4 equal to 1. Again we can rewrite this. The above equation can be rewriting like this. Y1 square by 64 can be written as 8 square and 4 can be written as 2 square. So we can obtain the equation like this. Y1 square by 8 square plus y2 square by 2 square is equal to 1. And this is the equation which is of the form of a conic section called ellipse. So we can say that this conic section, the quadratic form, given quadratic form represents the conic section and ellipse. Now we have to find out the eigenvector corresponding to lambda equal to 2. So we have to identify a minus lambda I, that is a minus 2. a minus 2I. So we make the corresponding change on the principal diagonal elements, that is 17 minus 2 minus 15 minus 15 17 minus 2. So we obtain a matrix like this: 15 minus 15 minus 15 15. So we write that particular matrix in matrix form of equations: 15 minus 15 minus 15 15, x1 x2 is equal to 0. So we obtain an equation in x1 and x2. The equation is minus 15x1 15x1 minus 15x2 is equal to 0. So we can write it as 15x1 is equal to 15x2, cancelling 15 from both sides. So x1 is equal to x2. So we can write it as x1 is equal to x2. If x1 is equal to 1, x2 is also 1. So the eigenvector corresponding to lambda is equal to 2s 1 1. The eigenvector x1 is 1 1. The normalized form of x1 is square root of 1 square plus 1 square, which is equal to square root of 2. Now we have to consider the next eigenvalue, lambda equal to 32. Now we have to find out a minus 32I. So the transformation should be applied on the diagonal elements: 17 minus 32 minus 15 minus 15 17 minus 32. So we obtain a matrix like this: minus 15 minus 15 minus 15 minus 15. Now we have to write down the corresponding matrix form, and we obtain a particular equation like this: minus 15x1 minus 15x2 is equal to 0. So minus 15x1 can be written as equal to 15x2. x1 is equal to minus x2. So if x1 is equal to 1, x2 is equal to minus 1. So the eigenvectors are: eigenvector corresponding to lambda equal to 32 is 1 minus 1. 1 minus 1. So the normalized form of x2 is square root of 1 square minus 1 square plus minus 1 square. It is equal to square root of 2. Now we obtain the two eigenvectors. So now we have to create the normalized model matrix. Normalized model matrix can be identified as eigenvector by the normalized form of their corresponding eigenvector. So the first column indicates the first eigenvector, that is 1 1 is the first eigenvector divided with its normalized form. So 1 by square root of 2 and 1 by square root of 2. The second eigenvector is 1 minus 1. The normalized form is square root of 2. So 1 by square root of 2 minus 1 by square root of 2. Now we have to consider the principal axis form: x is equal to ny. So x is same as x1 x2, and n is the normalized model matrix, y is y1 y2. So we can write it as xy is equal to 1 by square root of 2 in 1 by square root of 2, 1 by square root of 2 minus 1 by square root of 2 into y1 y2. We have to perform matrix multiplication on the right hand side. So it will become x is equal to 1 by square root of 2 y1 plus 1 by square root of 2 y2, which can be written as y1 plus y2 divided by square root of 2. Y can be written as 1 by square root of 2 y1 minus 1 by square root of 2 y2, which is equal to y1 minus y2 by square root of 2. So this is the principal axis form of given quadratic equation. Thank you.